Hi, I'm Rob Stevens. This podcast is about blood gas analysis, acid-base balance. Don't worry if you don't understand it or you don't know the answer, because we'll be talking through the various options. Okay, why don't you pause the podcast now while you read through the case, think about it, and look at the various answers. Okay, let's think of this case then. Again, the three things: pH, CO2, and the metabolic component, which is base excess or bicarbonate. So the pH again is normal, a normal pH. So either the person has no acid-base disturbance or they have a fully compensated one. Next, the CO2. The CO2 is not normal, it's raised. A raised CO2, as we've learnt before, causes a respiratory acidosis, or is a respiratory acidosis, we could strictly say. So, a respiratory acidosis means that CO2 is raised. Let's have a look further. The bicarbonate and base excess are both raised, which is a metabolic alkalosis. So the alkalosis will, of course, push the pH up towards normal. So let's look at the options. Metabolic acidosis with full respiratory compensation. Well, a metabolic acidosis would be where the bicarbonate or base excess is low. And we can see it's raised here. So it's neither A nor B. It also can't be C, because C includes metabolic acid, the phrase metabolic acidosis, or mixed metabolic and respiratory acidosis. Well, it is a respiratory acidosis in terms of C, but it's not a metabolic one. So it's not A, B or C. Okay. D, respiratory acidosis. Well, it is a respiratory acidosis because the CO2 is raised, and there is full metabolic compensation because the pH is normal. It's not E. It would be E if the pH was not normal. But the pH is normal, so it's number D. A respiratory acidosis because the CO2 is elevated, with full compensation because the bicarb is not normal, but the pH is.